Very pleasant morning to one and all join here. Myself, Dr. V Nirmala, Assistant Professor, Department of Statistics, Sri Sharada College for Women, Autonomy, Salem. Today I am going to present the topic properties and assumptions, applications of t-test and single mean, difference between two mean and paired t-test and its real-time applications, simple problems. The small sample theory, the sample size should be less than or equal to 30. It is known as small sample. For example, of the some statistical distributions are t, t distributions, f distributions, and chi-square distributions. A study of sampling distributions for small sample is known as the small sample theory. Since in many of the problems it becomes necessary to take a small sample size, considerable attention has been paid in developing suitable tests for dealing with problems of small samples. The greatest contributions to the theory of small sample is that Sir William Gosset and Professor R.A. Fisher in the year of 1905 under the pen name student. A sample is small when it consists of less than 30 items, that is n less than 30. Small sample t-test. T-test when the sample size is 30 or less and the population standard deviation is unknown, we can use t-distributions. There are three types: test of single mean, test of significance of difference between two mean, that means the independent sample t-test, test of significance of difference between two means, dependent samples, that means the same group can be considered for two different situations. T-test for single mean. The first step, we should write the null hypothesis. Mu is the population mean. We should compare the population mean and sample mean. Alternative hypothesis is just opposite of null hypothesis. There is no significant difference is the null hypothesis statement of population mean and sample mean. The alternative hypothesis will be there is a significant difference between the sample mean and population mean. The test statistics is nothing but the formula. Applicable formula is x bar minus mu into root n by s. Here x bar is the sample mean, mu is the population mean, n is the sample size, and s is the standard deviation of the given sample. Slide, the t-test formula is given. The t-distribution has been derived mathematically under the assumptions of normally distributed population, which is the main assumption for applying t-test for small sample. Here the standard deviation formula is summation x minus x bar whole squared by n minus 1 under the root. Here n is the sample size, x and x bar is x is the samples and x bar is the sample average. We should calculate what are the difference between actual sample and average, then take square of these values, and finally we should add it and substitute here. And what is the sample size also? Simplify this, it will be the standard deviation. Properties of t distribution. The variable t distribution ranges from minus infinity to plus infinity. Like the standard normal distribution, the t distribution is symmetrical and has mean 0. The variance of t distribution is greater than 1, approaches the variance of the standard normal distribution as the sample size increases. Applications of the t distribution. The following are some of the categories in which test used to test the significance of the various results obtained from small samples. To test the significance of mean of a random sample, test the difference between two group of samples, test the difference between the same group in different situations. T statistics definition. If x1, x2, x3, etc. xn is the random sample of size n from a normal population with mean and variance, the student t-test is defined as t is equal to x bar minus mu by s divided by root n. Here we can write it as x bar minus mu into root n because denominator will be equal to the numerator. So we can write it as this picture. You can see the comparison between the normal curve and corresponding t distribution curve. It's looking like almost similar. When it will be equal means the sample size is high. The t distribution goes to the normal distribution. Test statistics, which is the important step. There are five steps we have applying the t test for any real time applications. We defined our t test as follows. Here we denoted as determinant symbol because the final result can be plus or minus values, but we should consider only the positive value. Then the follows the students t distributions with n minus 1 degrees of freedom. Here n is the sample size, minus 1 is the constant. For example, sample size may be 10 means 10 minus 1 9, 9 is the degrees of freedom. Based on the degrees of freedom, we can calculate what is the table value. Significance level. Let us consider significance level alpha is equal to 5%. Critical value at 5% level of significance, the critical value of alpha where degrees of freedom V is n minus 1. For instance, the calculated value less than or equal to table value, it falls the acceptance regions. The null hypothesis is accepted. Otherwise, it should be rejected. The t-test is introduced in the year of 1908 by William Shelley Gossett. The Gossett published his mathematical work under the pen name of student. The definition of t-test is the method of testing hypothesis about the mean of small sample drawn from a normally distributed population when the standard deviation for the sample is unknown. Assumptions of t-test. Dependent variable or interval or ratio. The population from which sample are drawn is normally distributed. Samples are randomly selected. The group have equal variance, homogeneity of variance. The t statistics is robust. It is reasonably reliable even if assumptions are not fully met. Applications of t-test are the calculation of confidence interval for a sample mean to test whether the sample mean is different from a hypothesized value, to compare mean of two samples, to compare two samples mean by the group. Types of t-test. Already we discussed there are three types. The single mean sample t-test, we have only one group. Want to test against the hypothetical mean, that means the population mean. The second type of t-test, we have two types of samples. There are two means, no relations between two groups. For example, when we want to compare the mean of uh, t distribution samples group with place by group. Paired t-test, it consists of samples of matched pairs of similar unit or one group of units tested twice. For example, difference of mean pre and post drug intervention. One sample t-test. It is used in measuring whether a sample value significantly differ from a population value. For example, a research scholar might hypothesize that on an average it takes 3 minutes for people to drink a standard cup of coffee. He conducts an experiment and measures how long it takes his subject to drink a standard cup of coffee. The one sample t-test measures whether the mean amount of time it took the experimental group to complete the task varies significantly from the hypothesized 3 minutes value. Test of significance for mean hypothesis. We set up the corresponding null and alternative hypothesis as follows. Such not such that we can write the hypothesis statement in symbol or statement. In symbol, you can compare the sample mean and population mean. In words, we can write it as there is no significant difference between the sample mean and population mean. The alternative hypothesis, just strike out the equivalent. That means the opposite statement of null hypothesis will be the alternative hypothesis. Next step we should measure what is the significance level. Let us consider the significance level. Commonly, alpha is equal to 5%. Critical value at 5% level of significance, the critical value will be 5. The degrees of freedom V is equal to n minus 1 for single main t-test, which means the 95% confidence interval is having in this type of significance level. Test for single mean. There are five steps we have to follow while solving this type of t-test. First step, we should write what is the null hypothesis statement. Next, what is the alternative hypothesis statement. Then, what kind of formula we have to use for our research problem, which it will be the test statistics. Third step. The fourth step, what is the degrees of freedom value, which is based on the sample size. And finally, we should compare with our analytical value and table value. Finally, we can write the inference based on the final result. For one sample t test, t is equal to x bar minus mu by s by root n. Here t is the t is test statistics, x bar is the mean of the sample, mu is the comparison mean, that means the population mean, s is the standard deviation, n is the sample size. Research statement is given here. For example, t-test for single mean. 10 individuals had taken an exam and we want to test whether their scores all together are significantly different from the score of 100. Here t is equal to x bar minus mu by s by root n. The values of x bar, it will be 107.8 and population mean 100. Standard deviation 5.35 and the sample size is 10. Finally, we just simplify this, it will be 4.6. Here, 4.6 is our calculated value. Our table value will be that based on the degrees of freedom. Our degrees of freedom is 9. That means n minus 1, 10 minus 1, 9. The corresponding value will be the table value. Need to calculate the degrees of freedom. Here the degrees of freedom simply the size of samples. Therefore, the degrees of freedom n minus 1, 10 minus 1, 9. Now we will refer to a table to determine the critical t value for 9 degrees of freedom at the 0.05 level of significance. Looking at the t table, this value is 2.26. Since our calculated t value is 4.61, which is mentioned the previous slide, which is greater than the critical value 2.26. So we can state that the score of our samples of 10 individuals differs significantly from the scores of 100. So we should reject the null hypothesis. The t distribution table, we can see here the degrees of freedom 9, the corresponding 0.05% level of significance. The table value is 2.262. If suppose in our research statement we may consider the 0.01 means the corresponding value will be 3.250. To test the significance of the mean of a random sample, t is equal to x bar minus mu into root n by s. S is nothing but is the standard deviation of the sample. The formula for standard deviation is root of summation x minus x bar whole squared by n minus 1. Here x bar is the sample mean, mu is the population mean, n is the sample size, s is the standard deviation of the sample. The problem statement: the manufacturer of a certain make of electric bulb claims that his bulb have a mean life of 25 months with the standard deviation of 5 months. A random sample were taken. Life in months 24, 26, 30, 20, again 20 and 18. Can you record the producer claimed to be valid at 1% level of significance? The table value will be 5% degrees of freedom, it will be 4.032, because here you see the number of samples is 6. The degrees of freedom for t test is n minus 1, 6 minus 1, 5. 5 is the degrees of freedom. Null hypothesis statement. We can write the null hypothesis statement. There is no significant difference between the mean life of bulbs in the sample and that of the population. The first column of the table, which is already we have not question 24, 26, 30, 20, 20 and 18. The total of the samples is 138. The second column, x minus x bar. We should calculate what is the x bar value for given values. The x bar formula is summation x by n. Summation x is 138 divided by 6. 6 is the number of items. So we should calculate what is the average value and minus x bar 24 minus x bar value. Then calculate what is the difference between these two values and write in the second column. The third column you just take square of the second column. Finally, we should add the what is the total of the third column. It will be 102. The x bar is 23. So 24 minus 23 it will be 1. 26 minus 23 it will be 3. 30 minus 23 it will be 7. 20 minus 23 it will be minus 3. Again 20 minus 23 it will be minus 3. 18 minus 23 it will be minus 5. The x bar formula summation x by n. The total of x is 138, the sample size, then divided by n is the number of items. 138 by 6 is 23. 23 is the mean of sample size x bar. S is root of summation x minus x bar whole squared by n minus 1. The last column total summation x minus x bar whole square, which is 102. Under the root 102 by 5 to be 4.517 is the standard deviation. T-test formula is x minus mu by s divided by root 10. So just substitute these calculated values in our test statistics formula. X bar is 23 and mu is 25, which is given in our question, and the average mean life of the electric bulb 25. So divided by, yes, just now we calculated 4.517. Then root n is the sample size 6. The difference between 23 minus 25 will be 2. 2 divided by 4.517 into root of 6. It will be 1.084. The calculated value t is less than the table value, so null hypothesis is accepted. The inference of this problem is there is no significant difference between the mean life of bulbs in the sample and that of the population. Problem is also given here. The lifetime of electrical bulb for random sample of 10 from the large consignment is given below. Can we accept the hypothesis that the average lifetime of bulbs is 4000 hours? The total number of items are 10. The lifetimes in 1000 hours. That means 4.2 is 4200. 4.6 means 4600 house. We should consider like that. The table value for test statistics at 9 degrees of freedom is 2.262. So now the same step we have to follow for solving this problem. The null hypothesis, there is no significant difference between the mean life of bulbs in the sample and that of the population. We should write the given values in column wise in the solution part. Then second column, what are the difference between actual sample values and its sample mean. The sample mean is 4.4. So 4.2 minus 4.4 minus 0.2. You just calculate similarly at the end of the value. And the third column, you just take square of second column. The total of the third column 3.12. Here the x bar summation x by n 44 by 10 4.4 is the sample mean, and standard deviation is 0.589. The third column total divided by n minus 1. Here 10 is the sample size, 10 minus 1 9 is the degrees of freedom, and you just simplify this 3.12 by 9 under the root, it will be 0.589. The main t-test formula is x bar minus mu divided by s by root 10. We should substitute these values in this formula. 4.4 minus 4, 4 is the sample average which is given in our question. So what are the difference between these two values, and simplify it, its final value will be 2.1. The calculated value t is less than the table value, so null hypothesis is accepted. The inference of the problem is there is no significant difference between the population life of mm, bulbs in the sample and the population. Problem is also given in this slide. In your free time, you should calculate the same steps and formulas you can follow and simplify it. The degrees of freedom and table values is also mentioned here. This problem is also homework problem, practice problem. The answer of the problem is also given here. 1.54 is the final value. The table value is also available 2.262 because 10 samples are that 10 minus 1 9, the corresponding table value will be 2.26. Independent t-test. The second type of t-test, independent sample t-test, compares two means. Independent sample t-test is also called a unpaired t-test or two sample t-test. It is the t-test to be used when two separate independent and identical distributed variables are measured. For example, comparison of quality of life improved for patients who took drug, and comparison of mean cholesterol level in the treatment group with the placebo group after administration of t-test drug. Second type of t-test, the random sample of each population is used. The random sample are each made up of independent observations. Each sample is independent of one another. The population distribution of each population must nearly normal. The independent sample t-test consists of a test that compare mean value of continuous level in normally distributed data. Standard t distribution table is mentioned here. Testing difference between two samples, independent samples. The formula is x bar 1 minus x bar 2 divided by x into n1 into n2 divided by n1 plus n2. Here x bar 1 and x bar 2 are the first and second sample respectively. N1 and n2 is the first and second observations respectively. S is the combined standard deviation. The formula is also given here. Summation x1 minus x bar whole square plus summation x2 minus x bar whole square divided by n1 plus n2 minus 2. Kindly note it, the degrees of freedom of second type of t-test is n1 plus n2 minus 2. This is the research statement. The two types of drugs were used on 5 and 7 patients for reducing their weights. The weights were is also followed the drug A and drug B. The number of items in drug A 5, the number of samples in drug B is 7. Kindly listen here, the sample size can be varied while applying second type of t-test. It can be differ or it can be equal. The construction of table, before that we should write what is null and alternative hypothesis statement. The similar statement can be used. There is no significant difference between two types of samples, two types of drugs, two types of treatment, anything we can consider based on your research statement. And we should consider the two samples in column wise x1 and x2. The second and fifth column is similar calculations we should follow like as the single min t-test. Then take square, it will be the third and sixth column. What is the total of third and sixth column? 10 and 44, which is enough for further simplification. One is 12, x bar 2 is 11, s is 2.2, 2.324. The main test statistics formula is also there. We just substitute these values in our test statistics t value. Finally, we got 0.735. Comparing the calculated and table value, the calculated value of t-test less than the table value, so null hypothesis is accepted, which is the inference of this problem. This problem is also given in this slide. Values and final result and null hypothesis statements is also mentioned in this slide. Simplifications and inference is also there. More practice problems also given in this slide and next slide. And practice problem. Other type of t-test is paired t-test. A paired t-test is used to compare two population mean, where you have two sample in which observation in one sample can be paired with observations in the other sample. The comparison of two different methods of measurements or two different treatments where the measurements treatments are applied in the same subject. For example, pre-test and post-test samples in which a factor is measured before and after an intervention. Crossover trials, the which individuals are randomized to two treatments and then the sample individuals are crossed over to the alternative treatment. The formula for paired t-test d bar into root n by s. D is nothing but the difference between first and second sample, and standard deviation is yes. The S formula is root of summation d minus d bar whole squared by n minus 1. Here the third type of t-test, the degrees of freedom is n minus 1. The problem statement, to verify whether the course in accounting have improved performance, a similar test was given to 12 participants both before and after the course. The original marks recorded were 44, 40, 61, 52, 32, 44, 70, 41, 67, 72, 53, and 72. After the course, the marks were recorded in the same order: 53, 38, 69, 57, 46, 39, 73, 48, 73, 74, 60, 78. Test whether the course was useful. The before scores and after scores also mentioned, so we should use the paired t-test formula. The table value is 2.20 because the number of samples are 12, 12 minus 1, 11. 11 is the degrees of freedom. The participants is 12. The null hypothesis is there is no significant difference between the marks obtained before and after the course. That is, the course is not useful. The alternative hypothesis, the course is useful. So the before and after first and second test were mentioned in column base, and what are the difference between first and second sample, which is mentioned in the third column, and fourth column is nothing but take to square of previous column. The total is 578. The simplification of paired t-test, the main formula summation d by n d bar into root n by s. The d bar is the average for difference. Summation d by n 60 by 12, it will be 5. So standard deviation formula is summation d squared minus n into d bar whole squared by n minus 1. The simplifying, you just substitute these values under the root of 578 minus 12 into 5 whole square divided by 12 minus 1. So you simplify it, and finally we got 5.0.3 is the standard deviation value. The test statistics value is d bar into root n by s. D bar is 5 into root 12 by 5.03. It will be the calculated value. The calculated value t is greater than the table values, so the null hypothesis is rejected. The inference of this study is the course will be very useful. More practice problems also mentioned, and its answer also available. The degrees of freedom and its table values also mentioned. You please try it. Thank you for watching.